Okay. So we are going to start in, again, the back of your packet. And this is question number 6, which is right underneath the question that has this table. So it is, the top of it would be this sheet right here. So flip 3 pages and scroll to 6. You guys find that okay? Okay. So it says, suppose that the durations of a high school baseball game are approximately normally distributed, with a mean of 105 and a standard deviation of 11. Find the probability that a randomly selected high school baseball game lasts less than 115 minutes. All right, so what are we going to draw for these? The curve, the normal distribution. Okay, so I have a mean equivalent to 105 minutes, and I would like to find the probability that the baseball game is going to be less than 115 minutes. So I am going to shade my area under the curve that is less than that interval. I'm going this way now. So because I'm going to the left, my lower bound number is that standard value that I've had you use for all of these, because this is calculator now. So this is negative 1E99. And we'll talk about how to put that in the calculator again too, in case it's not there anymore. So now, again, all you need to write for the purposes of your test is your diagram and your calculator instructions. So I'm going to write this first and we'll go to the calculator second. My lower value is going to be negative 1E99, which again just represents a very tiny number that you are not lower than. My upper bound number, do you guys remember what we used? 115, yeah. And then I am going to go mu for my mean, which should always be provided to you, and that was 105. And then I'm going to do sigma. And sigma was equal to, I'm looking for it, 11. So my standard deviation. So now I'm going to place this into the calculator and do a normal CDF. So I'm going to grab the calculator and I want to go second vars down to number 2, normal CDF. Now I need to fix my screen and maybe some of you do as well. So I'm going to hit clear. I'm going to go -1. And to get the E, this is scientific notation. You are going to hit second, comma. So second, comma. Did everyone find that? Okay. And then 99. Upper bound value was 115, where my mu was equal to 105 and sigma was equal to 11. Down and then enter, and then enter. Everyone get approximately 82%? Okay, so I'm gonna go 4 decimal places and leave it at that. So I have an answer equivalent to 0.8183. 0.8183. 0.8183. That's it. All right, next case. So for letter H, I am now looking for where am I more than 100 minutes. So once again, I'm going to draw my normal distribution. I am going to label my mean, which is right towards the center because this is a symmetric distribution. And I would like to now be more than 100. So I am going to shade this direction now. the exact opposite of what we just did. So now what I want instead is an upper bound value that I will never exceed. So a nice standard value that we can use is 10 raised to the 99th power. So in my calculator, I am going to put my lower bound number at 100 this time. So this is always now my lower, right over here. I'm going to do my upper value as 10 raised to the 99th power, where mu is still equivalent to 105, and sigma is equal to 11 still. All right, so then we're going to just flip around in the calculator. So in the calculator, I am going to go second bars, normal CDF, lower bound number is equal to, what was it, 100? And upper bound value is going to be 10 raised to the 99th power, and everything else remains the same. So you're going to go down, 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 enter. And then there we go. I got 0.6753. So 0.6753. 0.6753. All right, is anyone having any difficulty at all getting this? Good. All right, we got one more now. So now we want to be the last scenario that we discussed, and this is your in-between case. So in between, and what is great about the calculator is you no longer have the need to do these twice and subtract them from each other. So I'm going to be between 90 and 110. So 90 and 110. And I'm going to shade in between these. And that is my area under the curve that I'm going to calculate with the normal CDF. So now my lower value changes again, and it becomes 90. My upper becomes 110 instead. So now I'm going to go, I'll write the screen first again. Lower is 90. Upper is now 110. My mu is equal to 105 still, where sigma is still equal to 11. And that gets placed in the calculator one more time. And that is your third and final scenario with these. So calculator, you're going to go second bars again. Number 2, normal CDF. Lower bound value was 90. Upper bound value was 110. Everything else remains the same. Enter. 0.5889. All right. Is everyone feeling okay with those calculations? Yep. Oh, that will be given to you. Okay. Yep. Also given to you. Okay. You have a question. If you are asked to find the mean and the standard deviation, that is when you have a list of data that you type in and do one bar stat. We are getting to that. You have a good question. Yep, that's coming in a second. Not a second, but a couple minutes. All right, this is on your same page, but I just want you to find number 7 now. So number 7 is right below for you guys, right? Okay. Yep, I just see that formatting. So number 7, you are given 60% of all customers of a large insurance agency have automobile policies. That is event A. So probability of event A is equal to 0.60. I would strongly recommend when you read a question to do little things like this on the side to make it easier for yourself. Event B, I covered that. Whoops, what does that say? 40%, sorry. So probability of event B is equal to 40%. And then I am given that the probability that they will have both types of policies, so the probability for A and B. This is again what we call an intersect. So that's when they both occur at once. And that was equal to 0.25. What is the probability of P or B? So that is your union. So I'm going to apply the union rule. So I'll say X because that one's unknown. So to do the union rule that we've discussed in the past, I'll write this first. Your rule goes, you want to make sure you know this, the probability of A or B is equal to the probability of event A plus the probability of event B minus the overlap, which is the probability of A and B occurring together. And again, if you are a visual person, just please think overlap right from that Venn diagram, because you don't want to double count. So I am now going to plug these in. So I get 0.60 plus 0.40 minus 0.25 equal to X. I think you guys can probably do this in your heads. 1.0 minus 0.25 would just be 0.75. And yep, you can leave it just like that, no problem. How is that union rule, okay?
So what would we do by the overlap?
If that was not given, then this would be.
Oh,
Yep, good question, because I do only have one unknown. Yep. So you just always plug in for the 3 out of 4 that you have. All right, so now I would like you guys to flip right on over. So you can flip past these. And you're going to flip right to this sheet in the very back of your packet that just says additional review. We're going to run through some of these too. Actually, pretty much all of them. So it says Eleanor scores a 680 on the math part of her SAT. The distribution of SAT scores in reference to the population is normal, so normal curve. A mean of 500, standard deviation of 100. So Gerald takes the ACT and he scores a 27. Also normally distributed with a mean of 18, standard deviation of 6. Assuming that both tests measure the same ability, who has the more impressive performance? What you need to do is standardize these scores. You are going to standardize your scores to compare them. So you're going to use the formula. So your formula is the X minus the mu divided by the sigma. So basically, per score minus the average person's divided by standard deviation. You do not have to write that formula verbatim like that on your test. All I need to see is this. So this first side is going to be for Eleanor. I need to see this part. Her score was 680. The average person scored a, looking for it, 500. And then divided by? Thank you, 100. That's the part I need to see from you. That's it. And of course, an answer too. All right, so we're going to get 680 minus 500 divided by 100. And her z-score is 1.8. And it's positive, indicating that she scored better than the average person. Now you're going to standardize for Gerald. So for Gerald, same thing. His score minus the average person's score. What did he get? A 27. Average person got an 18. And standard deviation of 6. That looks like 1.5 to me, right? Divided by, yep. So this is equivalent to 1.5. He still scored above average, but who did better? Eleanor, yep. So we're gonna say Eleanor has a higher Z-score, thus performing better. So she has a higher Z-score, indicating better performance. They're pretty close. So indicating better performance. So you have a question just like that. But I think you guys would agree, very straightforward, and it's just used for comparison. Is that one okay? Yeah, so the formula you have to know is just this. Just the fraction. All right, so next. SAT scores are originally scaled so that the scores for each section are approximately normal. Mean of 500, standard deviation of 100. So use your calculator. You may cross this part off. Calculator is sufficient. So I'm going to do a normal CDF. These I'm going to kind of fly through a little bit quicker because we just did some. So my mean in this case is equal to 500. And I want to score at least a 700, which means 700 or better. So in the calculator, I am going to do lower. The lowest score she wants is a 700. The upper is when we change this to 10 to the 99, where your mean was equal to 500 and your standard deviation was equal to 100. All right, so you're going to go normal CDF again. And I'm going to go 700, 10 raised to 99, 500, and 100. And I have an answer here of 0.0228, which again, that makes sense because it's hard to score that high on SATs. So it should be a small percentage. Now I'm going to do it again. In between 500, 440, 560. What I'm hoping by doing a bunch of these is it's building your confidence with them. Because they are not bad to do. You just need some practice and repetition. All right, so now my lower bound value becomes 440. And my upper bound value becomes 560. And nothing else changes. So 500 still. And 100. So that's going to get placed right in your calculator again. So normal CDF. So 440, 560. And this is a greater probability because it represents a larger area under your curve. And I got 0.4515. Okay. Questions on that, or is it getting better? Good. Lastly, with this one, at most 360. So again, I'm going right down from the center of my distribution, representing my mean. At most 360 means which way am I shading? To the left. Lower is over here. For lower, we use -1 E99. So on my screen, I'm going to type -1 E99. And my upper is 360. And my mu is 500. And sigma is 100. All right, so those are your three cases once more. So I'm going to go second bars, normal CDF, -1E99, upper 360, and then nothing else changes. Also, a very small percentage. So 0.0808. All right. So next, number 1 here. Abby wants to take 3 standardized tests. She scores 620 on all of them. Using z-scores, determine which test she performed the best on. So you're going to do your 3 calculations super quick here. So for test A, she scored a 620 minus average person scored 505 divided by 80. Again, just repetition with this. So I'm going to type that in and divide by 80. Z-score equivalent to, and you want obviously a decimal. So 1.4375. Test B, 470 minus 505. This time she scored below average. And then divided by 120. So I'm going to go 470 minus 505 divided by 120 means negative 0.2917. Oh, I'm sorry. Thank you. Hold that thought. Thank you. I changed the wrong one. So she's still 620. Okay. Thank you for catching that. Minus the 470 divided by the 120. Okay, so now this is coming back positive again. Minus 470 and divide that by 120. I got 1.25 this time. And the last test, she still scores 620, but the mean this time is a bit higher, 550, divided by standard deviation lower. So there's less variability is what that means. So 620 minus 550 divided by 29. And I got 2.41. So what test did she score the best on? Testy. So test. All right, you guys get comfortable with formulas? Okay. So number 2, fast and easy. Probability of someone having blue eyes is 15%. So 0.15. What is the probability that 3 people are chosen at random and neither has blue eyes? So the probability of not having blue eyes is what we refer to as the complement. So 1 minus 0.15 is equal to 0.85. And these are all independent events. So I do person number 1 times person number 2 times person number 3. And that's it. So just like your homework problem. And that is all the work you need to show on your papers. I got 0.614. I'll go one more. All right, questions on number 2, guys. Okay. Next, we've got a two-way table to complete. I'm gonna quickly give you these totals. All right, so we're looking at how many times people go shopping. Total of your first row is 135. Next total is 685. Next is 407, followed by 323, and 202, and 1,752. Last row is 962, and 620, and I've got 170. And all you're going to compute on here is just a couple quick probabilities. So what is the probability that a customer is chosen at random of the 40 to 49-year-old people, given that he or she visited 3 times? So I'm going to do probability, 40 to 49, given the specific condition that you visit 3 times. In my table, I'm going to circle these in red. So this question will be the red ones. So of the visit 3 times means I am dividing out of 170, and just in this column I have 36. Okay, and you can get a decimal. That comes back as 0.2117. All right, next one I'm going to do in blue. So it says, what proportion of customers? Of customers means I am using that 1,752 number. That is my total. I'm going to keep reading now. Are 25 to 39 and went to the supermarket twice. So I'm going to find where that box is. And went twice. 230. So here's how you write this. We have the probability that they are 25 to 39, and which means intersect twice. So they're going to visit 2 times. So that was equal to what number did I say? 230 over 1,752. And decimal is 0.1313. All right, next I'm going dark blue. So these will correspond. So given that he or she went to the supermarket once, that becomes my total. And we want them to be 50 to 64 years old. All right, 1 visit and 50 to 64 years old. So 1 visit, how many people? 962. And then I'm dividing, what did we have here? 50 to 64? What's that number? So 186 over 962. Over 962. Decimal equivalent is like 0.19. Problems on any of those guys? Okay. So number 4 gives you a hypothetical 1,000 table, and it asks, if you skim this, test for independence. This is my recommendation, and I would really like it if you used it, because it helps, I promise. So I am going to only look at this first condition. So are the events a randomly selected person watched an online ad? Stop. Just take this. Probability of ad. Please physically circle this in your table. How many watched the online ad? 750 out of 1,000. If you do little things like that, you now have a 50-50 shot of getting this right. I know that my next fraction I compare this to, just look, is either that over that or that over that. Okay? So we do this part in orange now. So now we want the randomly selected person does not vacation in New York. That's this column. So probability of ad repeats given no vacation equals, circle, circle, 450 over 600, which actually is also 0.75. So are these independent events? Yes, they are equal probabilities. Okay, so I'm going to keep that short and simple for you. All right, when you're ready, flip to the last couple, which are very quick.
So when you're doing test independence, the first one that you do is always like the first one.
and they literally stop reading. And it's always out of the grand total. Yep, so it's not a conditional probability. Yep. Great question. Next. Students selected at random from a very large population, and the probability that the student has a smartphone is 0.68. And it says that is event A. So probability of event A is 0.68. Probability a student has an electronic tablet is 0.36, and tablets are event B. Or, I mean, I guess you really could use whatever you'd prefer. Next, the probability that the student has a smartphone and a tablet is 0.09. Please keep in mind when you do probability that these answers should always be less than 1. So the smaller number always has to go on top. Okay? So we want the probability of A given B. So technically, your formula is the probability of both of these conditions together over just the probability of event B. But you do not have to write that out if you don't want to for this one. So all I have to do is 0.09 divided by 0.36. Answer, 25%. 1/4. Okay. All right, so number 8. And this finally gets at your question. The number of sick days used by a small sample of employees over the past 2 years is listed below. Calculate the mean and the standard deviation. So this is finally a calculator one. So what you would do, because I'll just give you the answer here, is you would hit stat over to edit, and you would type the data. You quit out of that screen and you hit stat over to calculate, and you select option 1, which are 1 variable statistics. I'll do it right down here. My mean is X bar and standard deviation. So once you type those are going to be right off your screen. And these answers came back as the mean would be 6.533. I know you guys can type that. I'm not really worried. And then your standard deviation is 5.18. And then continuing, what percentage of scores fall within 1 standard deviation of the mean? So what you do is we do 6.53 minus 5.18, and my lower value I want to be between comes back as 1.3. And then I do the upper. So I go 6.53. This is the thing we did with the dinosaurs, the compies, plus 5.18. And then the high end of my interval would be at 11.713. And what I want to do is count the number of sick days that fall between 1.3 and 11.713. So this is my interval. So I'm going to go up in circle. That one does. That one does. That one does. 4, 5, 2, 10, 6, 7. How many did I just circle? 9. So 9 out of 15. And that is equal to, I think this is 60% if I'm not mistaken. 9 out of 15, yes, 60%. Which is because I kind of played around with some numbers.
What was the thing to do when you like round it up and down? Is that
Yeah, I mean, it would work with this. Yeah. Well, this actually gave you, it's because those were intervals or something. You won't need to do that. You'll just need to count your scores in between the values instead. Yep, so in between those two. So don't change those whatsoever, keep them exact. And then last. So this is a Venn diagram question, and those of you that don't prefer those, you can do a table, it's fine. So we have the probability she gets accepted is 0.6, he is 0.8, and the probability that these both get accepted is 0.50. The 0.50 is the value you want to begin with. So 0.50 is your intercept. So if her full circle is 60%, that leaves 10% remaining. And if his full circle is 80%, that leaves 30% remaining. Your complement right here is what's outside of the circle. So I'll do this first. 1 minus 0.10 plus 0.50 plus 0.30. And that would be equal to 0.10 or 10%. And then last two answers, compute A and N. So that's intersect. Intersect is just the 0.50. You don't have to show any work for that because it's already kind of done above for you. And then lastly, your A or N. On a Venn diagram, all you have to do is add across. So 0.50 and plus 0.30, 0.90. All right, so overall, we feeling okay on all that content? Pretty easy, right? Manageable? Okay, if you guys think of anything else when you're looking things over tonight, you know, we could take 5 minutes before you do your test tomorrow to kind of discuss those. If you finish super quick, you are welcome to start your assignments for the week, which are on Delta, so bring your Chromebook with you. Is there anything else? There aren't any extras, but you could redo any of those, and those are great. Yeah. Anything else, guys? All right. So we will stop there for today.